Hi. In the previous session we had introduced Fourier series and also we had done one or two problems. So in this session we will be taking up many problems related to Fourier series expansion. Okay, so since this is a problem session, I strongly suggest that you also take a pen and paper and do the problems along with me itself, so that you can also understand the lecture better. Okay, only if you do, you will understand, because it's basically a problem session. Okay, now before we start with the problem session, now let us recap the formulas once again. So the Fourier series expansion of a periodic function with period 2 pi. So we were discussing periodic functions with period 2 pi in the previous session. So this is the expansion of that function. It is a naught plus sigma n is equal to 1 to infinity a n cos n x plus b n sin n x. Okay, and these are the values of a naught, a n's and b n's. Okay, and basically the problems will be, you will be given a function f of x. For example, f of x is equal to x, and you will be given an interval in which it is defined. For example, if it is 0 to 2 pi, so your corresponding c to c plus 2 pi will be the given interval, and you have to substitute this x in the formulas of a naught, a n and b n and find the corresponding values, and then you have to write down the final expansion by substituting these a naughts, a n's and b n's. So this is the idea. Okay, so the question will be expand this function as a Fourier series expansion. That means you have to find out a naughts, a n's and b n's with respect to that function and write down the final expansion. Now some problems also may contain deducing results also. So you may have to deduce some results also in some problems. For that, probably you will have to substitute some value for x from this interval into the final expansion. Usually it will be 0, 2 pi or maybe the middle point, etc. Okay, so these are some concepts. And also I had discussed about Dirichlet's condition also. What does Dirichlet's condition say? Dirichlet's condition says that the Fourier series expansion would be equal to f of x at all points of continuity, and at all points of discontinuity the expansion would be equal to the average of LHL plus RHL. Okay, average means LHL plus RHL will by 2, and at the end points also the value will be simply be f of 0 plus f of 2 pi by 2, provided the interval is 0 to 2 pi. Okay, if it is minus pi to pi, it will be f of minus pi plus f of pi by 2. So this is the basic idea. Okay, and also I have emphasized that in some textbooks the Fourier expansion would be given by a naught by 2 plus sigma n is equal to 1 to infinity a n cos n x plus b n sin x, but in that cases the value of a naught will be 1 by pi. Okay, yeah, they are using this formula to make the symmetry between a naught, a n's and b n's. Okay, so you have to be careful of the text which you will be following. You can use any expansion which you like. Okay, and also one more thing I would like to say, that sometimes if you know the properties of even and odd functions, you can actually simplify certain problems. You know that if f of x is an even function, integral minus c to c f of x dx will be simply be 2 times integral to 0 to c f of x dx. Okay, and if the function is odd, this value will be 0. And I hope you know what is an even function. Even function is nothing but a function which has the property that f of minus x is equal to f of x. For example, your cos of minus x is cos x, or cos is an even function. Similarly, x square is an even function. Okay, and what's an odd function? An odd function is the property that f of minus x would be minus f of x. Okay, for example, sin x is odd function because sin of minus x is minus sin x, x is an odd function, x cube is an odd function. So there are many examples. And one more thing, the product of two even functions would again be even function, because they both when you take f of minus x in both the functions and take the product, no negative sign will be coming out. So product of two even functions will be even function. Product of two odd functions will actually be even function. Why? Suppose my function is x and sin x. Okay, now if I consider minus x and sine of minus x, what will happen? This minus is outside, the sine minus x minus will come outside. So effectively you have x sin x itself. Okay, so when you have two odd functions, two negative signs would come out when you substitute minus x. So in that case it will become an even function. Okay, and the product of an even function and an odd function is always odd, because when you substitute minus x from the even function factor, minus would not come out, but from the odd function factor x would come out, minus would come out. So altogether there will be minus sign. Okay, so these are some ways to simplify your problems. When you do the problems, you will understand these methods better. Okay, so for now just remember the formulas. We will be substituting these formulas for different functions, and then we will be finding the results. Okay, now let us try to do some problems. So please do it with me, only then you will understand. Okay, find the Fourier series expansion for f of x is equal to e raised to minus x in the interval 0 to 2 pi. Suppose this is a problem. Okay, so the first step, you just write down the expansion. It is nothing but f of x is equal to a naught plus sigma n is equal to 1 to infinity a n cos n x plus b n sin n x. This is the Fourier series expansion. Okay, if you want, you can write a naught by 2 also. So the corresponding a naught will be different. So here you need to find out the values of a naught, an's and also bn's. Now let us find it out. What's the formula for an? An is equal to 1 by 2 pi. The given interval is actually 0 to 2 pi e raised to minus x dx. So it is nothing but 1 by 2 pi e raised to minus x by minus 1 in the interval 0 to 2 pi. So it is 1 by 2 pi into e raised to minus 2 pi by minus 1, right, plus e raised to 0 by 1, that is just 1. So I think it is 1 minus e raised to minus 2 pi by 2 pi. Okay, please correct me if I am wrong. Okay, similarly go for a n. When you find the value of a n, it is simply 1 by pi integral 0 to pi e raised to minus x into cos nx dx. Okay, so when you write for the examination, first you write down the formula of a n, which is f is integral 0 to 2 pi. It's okay, 0 to 2 pi. So write down the formula for a n, which is nothing but 1 by pi into f of x integral f of x into cos nx dx, and then you substitute, because the formula would usually carry 1 mark. Okay, so you have to do that also. Okay, so I hope this is clear. Okay, now we have to integrate this. I had given the formulas for e raised to x cos bx and e raised to x sin bx in the previous session. Please go through that. If you know the formula, it is very simple. It is e raised to x by a square plus b square into a cos bx plus b sin bx. Okay, the integral of e raised to x into cos bx. So using that formula here, it will be simply be 1 by pi into e raised to minus x by 1 plus n square, because your a is minus 1, your b is n, e raised to minus x by 1 plus n square into minus cos nx, okay, plus n sin nx, and now this is a definite integral, so you have to apply the limits from 0 to 2 pi. So just substitute. So what will you get? This will be 1 by pi into, when you substitute 2 pi, it is e raised to minus 2 pi by 1 plus n square into it will be cos 2n pi, right, cos nx. So it is cos 2n minus cos 2n pi. So minus cos 2n pi, cos 2n pi is always 1, so minus cos 2n pi will be minus 1, okay, plus n into sin 2n pi. Now sin 2n pi, but sin 2n pi is always 0, so that will be simply this one, the upper limit. Now when you apply the lower limit, it will be minus 0. Okay, so when it is 0, it is 1 by 1 plus n square, so minus 1 by 1 plus n square into again minus cos 0, minus cos 0 is actually minus 1, cos 0 is 1, so minus cos 0 is minus 1, but it is lower limit, so we will be getting plus 1 there. Okay, and sin 0 is 0, so this is the value. So I think it is 1 minus e raised to minus 2 pi by pi into 1 plus n square. Okay, so please correct me if I am wrong. So it's straightforward substitution of the formulas. Let us just verify. So it is, I think it is a n is equal to 1 minus e raised to minus 2 pi by 1 pi n square plus 1, and a naught in this formula is 1 minus e raised to minus 2 pi by pi, because here they have taken a naught as the expression as a naught by 2. Since we have not taken that, your value will be simply 1 minus e raised to minus 2 pi by pi. Okay, so that is also clear. Similarly, you can find the value of bn also. Here you will be using the expansion of e raised to ax into sin bx. Recall the expansion, it is nothing but e raised to x by a square plus b square into a sin bx minus b cos bx. So in this expression, your a is actually minus 1, b is actually n. So just substitute. So we will be getting this as e raised to minus x by n square plus 1 into minus sin nx minus n cos nx. Just substitute. Please do it by yourself. You will be getting the answer, and the final answer would be this one. Okay, so I hope it is clear. So final answer, you have to substitute this value. So it is something but a naught plus, you know the value of a naught. So when you write the final answer, it is something but 1 minus e raised to minus 2 pi by 2 pi plus sigma n is equal to 1 to infinity. Write down the value of a n cos nx plus write down the value of b n sin nx, and keep it in a big bracket, because sigma is valid for both the terms. Okay, so that is it. If you want, you can simplify also, but that is enough. Okay, I hope it is clear. Okay, now let's move on to the next problem. Let us now find out the Fourier series expansion for f of x is equal to x minus x square. Okay, so please do it. You know already the expansion is nothing but f of x is equal to a naught plus sigma n is equal to 1 to infinity a n cos nx plus b n sin nx. You know the formulas of a n's and b n's. Please substitute and then find out. Okay, I'll just give a brief idea. If it is a naught, it is 1 by 2 pi integral minus pi to pi x minus x square dx. Okay, so when you integrate, it will be x square by 2 minus x cube by 3, then you can substitute from minus pi to pi, you can do it directly. Now I will give you another method also. If you consider this integral separate, suppose this is 1 by 2 pi minus pi to pi x dx minus pi to pi x square dx, you can see that this is an odd function, x is an odd function, so the value of this integral will simply be 0, and the value of this is an even function, x square is an even function, so the value of this integral will be 2 times 0 to pi. So this is actually minus 1 by 2 pi 1 by 2 pi into 2 times integral 0 to pi x square dx. So it is minus 1 by pi x cube by 3 in the limits 0 to 3. So I think it is minus pi square by 3. Okay, I have just used the properties of even function and odd function there, or else you can directly evaluate also. In that case, you will have to substitute it, and the calculation will be a little bit complicated, because you have to be careful here, because you have to substitute minus pi and pi as well. So you can also do it directly, or you can use odd or even function properties of integrals to simplify that. Okay, so please try to do it by yourself in any one of the methods. Okay, so that is it. Now we will find out the value of an. How will you find out the value of an? An is nothing but 1 by pi into integral minus pi to pi x minus x square into cos nx dx. Okay, this also you can do it directly by applying parts. You consider x minus x square as one block. Okay, and using that generalized parts also you can do it. So please try that way, but I will also give you a simple method by using this odd or even functions. Okay, just think here, you know that x is an odd function, cos nx is an even function, x square is an even function, cos nx is an even function. So the integrand is x cos nx minus x square cos nx. Okay, now x is an odd function, cos is an even function, so this will be an odd function. And again, x square is an even function, cos is an even function, so the product will be an even function. So this integral, if I simplify, it will be simply be 1 by pi into 2 times integral 0 to pi x cos nx would be 0, and it will be simply minus x square cos nx dx. So if you can do it like this, your integration work will be much simplified. Otherwise, there are possibilities of you making mistakes. So it is better if you could do it like this. Okay, so this is the value. So I hope it is clear. If you know the odd or even function property, you can easily simplify it like this. So now if you apply the integration by parts, the generalized integration by parts which I taught you in the previous session, so it will be simply x square into, okay, derivative of that, is sin nx by n minus, again, derivative of x square, which is 2x, and integral of sin nx by n is minus cos nx by n square, again, plus derivative of 2x, which is 2, and integral of this quantity, that is nothing but minus sin nx by n cube in the limits 0 to pi. Okay, so when you substitute 0 to pi, what will you get? You will be getting it as minus 2 by 2 pi pi, and it is x square sin n pi. Sin n pi is all, when you substitute pi here, it will be pi square sin n pi. So please write it down, only then you will understand. Okay, if you just listen to the lecture, you will not understand how this is computing. Only if you do with me, you will understand. Okay, so please try to do it with me. When you substitute the value of pi, it will be pi square into sin n pi. Sin n pi is 0, so it will become 0. Minus, it will be minus 2 pi, so it is minus of minus, so it is plus 2 pi cos n pi by n square. Okay, and when you substitute this quantity, it is minus 2 sin n pi is again 0, it will become 0, and when you substitute the 0 value, this quantity will become 0, this quantity will become 0, because x is 0, and this quantity also will become 0. So this is the final one. So the final answer here would be simply be minus 4 cos n pi by n square. If you know the value of n pi, cos n pi, it is minus 1 raised to n, so it is minus 4 into minus 1 raised to n by n square. That's the value of your an. Okay. So similarly, you can also find out the value of bn also. So try to do it by yourself. So I hope it is clear. Cos n pi is minus 1 raised to n, because cos pi is minus 1, cos 2 pi is 1, cos 3 pi is again minus 1. So it is alternating in sign. That's it. So basically cos n pi is minus 1 raised to n. So we can write it like this, or you can simply write cos n pi also. Okay. So similarly, find out the value of bn and then write down the corresponding expansion. So this is the value of a naught. So minus pi square by 3. And this is the value of an, minus 4 into minus 1 raised to n by n square. Now find out the value of bn. So when you want to find the value of bn, it is 1 by pi into integral 0 minus pi to pi x minus x square into sine nx dx. If you remember the properties of even and odd functions, you know that x sine nx is actually even because x is odd, sine nx is odd, and x square sine nx is actually odd because your x square is even, sine nx is odd, so this is an odd function. So when you take the integral from minus to pi, this will be 0. So I effectively will get this as 2 by pi integral 0 to pi x sine nx dx. Now you apply the integration by parts. So it is 2 by pi into integral x into minus cos nx by n minus, okay, derivative of x which is 1, minus sine nx by n square. So that's it. So in the limit 0 to pi, so when you give pi, you will be getting, I think it is 2 by pi into minus pi cos n pi by n, and when substitute in sin n pi will become 0, and when substitute x equal to 0, this will become 0, and sin 0 is also 0. So the final answer would be minus 2 cos n pi by n. So I think it is minus 2 into minus 1 raised to n by n. Okay, so that way also you can find it out. Let us just verify. So so it is basically minus 2 into minus 1 raised to n by n. Okay, now we write down the final expansion. Now you already know the values of a naught, a n and b n. Just write down the final expansion. The final expansion would be, your a naught is minus pi square by 3. So it will be f of x is equal to minus pi square by 3 plus sigma n is equal to 1 to infinity minus 4 into minus 1 raised to n by n square cos nx plus minus 2 into minus 1 raised to n by n sin nx. Okay, so I hope that, I think that is the expression, minus 2 minus 1 raised to n by n. Okay, here it is minus 4 minus 1 raised to n by n square. So this was the expansion, and you have to make a deduction here. In the question there was a deduction question also. You have to show that 1 by 1 square minus 1 by 2 square minus 1 by 3 square. Okay, so once you have done it, you have to show that 1 by 1 square minus 1 by 2 square plus 1 by 3 square minus etc., which is equal to, I think it is pi square by 12. I don't remember it. Let's check it out. It is equal to pi square by 12. Okay, so we have to do it that way. So before if you do that, let us just expand it a few terms so that we can understand the series. So this is actually f of x is equal to minus pi square by 3 plus, if I just expand it, it will simply be minus 4, I can take it outside. So it will be minus 1 raised to n cos nx. Okay, so when it is 1, it is minus 1 cos x by 1 square, and when it is 2, it is minus 1 square, it is 1. So plus cos 2x by 2 square. Again, when it is 3, it is minus 1 the whole cube. So it is minus 1 by 3 cube 3 square cos 3x plus etc. And for sine terms, the expansion is, if I just take minus 2 outside, it will be minus 1 sin x by 1. Okay, again plus sine 2x by 2 minus sine 3x by 3 plus etc. Okay, so I need to get this expression. So if you compare these expressions, you can see that only terms involving 1 by 1 square, 1 by 2 square and 1 by 3 square are there. So this term would be coming out here, and this term would be not be present. So you have to make this as 0. Okay, so which substitution of x would make the entire signs as 0 in the interval? The interval is actually minus pi to pi. So there are many possibilities. You can give pi, minus pi, but the easiest one is if you just substitute 0, this entire signs will become 0 and your cos values would be 1. Okay, so what will you, so if I put x of x is equal to 0, your RHS would be minus pi square by 2 minus 4 into minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square etc. Only that much will be there. This will become 0, and it's 0. At 0, the function is actually, I think it is x minus x square. This is a point of continuity. 0 is this is a polynomial, so every point is continuous there. So 0 is also continuous. 0 is between minus pi to pi. So at the point of continuity, the given series will converge to f of 0. So the value will be simply be f of 0. What is f of 0? F of 0 is x minus x square. 0 minus c0 square, which is 0. So the value of 0 is this. So if you bring it back here, it will be simply be pi square by 3 is equal to minus 4 into minus 1 by 1 square plus 1 by 2 square minus 1 by 3 square. If you take minus outside, it will be 4 will be coming outside. So this will ultimately become pi square by 2 is equal to 1 by 1 square minus 1 by 2 square plus 1 by 3 square, etc., which is the required deduction. Okay, so in deduction problems, always remember, most probably if you apply the end points or the middle point, you will be getting the answer. Okay, but when you substitute this, remember that you have to write f of x should be, you have to check whether the point is a point of continuity or an end point also. Okay, if it is an end point, it will be f of minus pi plus the value at this value of the series at f of is, if suppose I am looking at the value of the series at x is equal to pi. Okay, the RHS you have to substitute just x is equal to pi, but the LHS would be simply be f of minus pi plus f of pi by 2. Okay, so we have to remember that at the end points it will be f of pi plus f of minus pi by 2. At points of discontinuity also it will be LHL plus RHL by 2. So we will be doing those problems also. At points of continuity it will be simply be f of x. Okay, so that is the idea. Okay, so this is the expansion. It is done here. Please go through it. Please rectify any mistake if there is any mistake also. So I hope it is clear. Okay, so moving forward, now let us find the Fourier series expansion of f of x is equal to x sin x. Okay, it's a very important problem. Okay, it's all very simple. Everything is just the same only. Okay, so you can't use odd and even functions in this interval because the interval is 0 to 2 pi. If it is minus pi to pi, you can simplify it. Otherwise, you can't use the property of odd and even functions. Okay, now I have to find the expansion of f of x, which is a naught plus sigma n is equal to 1 to infinity an cos nx plus bn sin nx. Okay, so basically in these problems, your integration of by parts, you have to be very strong. Okay, because you will be using that extensively in these problems. Okay, so when you find out a naught, what is the value of a naught? A naught is actually 1 by 2 pi integral 0 to 2 pi f of x dx. So this is actually 1 by 2 pi into integral 0 to 2 pi x sin x dx. So it is 1 by 2 pi into x minus cos x, okay, minus derivative of x is 1, derivative of minus cos x is minus sin x, so it is minus sin x in the limits 0 to 2 pi. So when you apply 2 pi, I think it is 1 by 2 pi into minus cos 2 pi, cos 2 pi is 1, so you will be getting as just minus 2 pi there, and sin 2 pi is 0, and substitute 0, you will be getting this as 0, this also will be 0, so I think the value is, you have to be careful here, I don't know whether I have made a mistake, so just check it out. So I think the value is minus 1, so it is x sin x, when you integrate x into minus cos x, okay, minus 1 into again minus sin x would be there, so I think it is, okay, so 2 pi cos 2 pi, so I think it is minus 1, you can let's just verify, x sin x is, okay, it is minus 1, okay, because here they have taken a naught by 2 only, so that's why they put it as minus 2. Since we are taking a naught, the formula of a naught would be 1 by 2 pi for us, so then for us the value would be minus 1. Okay, so that is clear, that's correct. Okay, now let us find out the value of an. Value of an is actually 1 by pi integral 0 to 2 pi x sin x into cos nx dx. Okay, so be careful here. So here the you can do it directly, the integration is not possible here because you have 3 functions are there. So what you cannot directly apply the integration by parts here. If it was 2 functions, you can easily apply, but for 3 functions it will be very difficult for you. So what you will do is that you actually are using the property of product rule of trigonometric functions to simplify, convert this 3 product function by 2 product function. Okay, so you know the product rule of trigonometric functions, 2 sin a cos b is nothing but sin a plus b plus sin a minus b. If you know this formula, this integrand could be written as, I will just write it here for it will be 1 by pi into integral 0 to 2 pi, think of this as 2 sin x cos nx, so it will be x into 1 by 2 because 2 is not there, so I have to supply 1 by 2, so 2 sin x cos x, it will be sin of a plus b, so sin of x plus nx, or it is sin of 1 plus n into x, okay, plus sin of a minus b, so it is x minus nx, so sin of 1 minus n into x. Okay, so be careful here, very simple thing, I am just used this formula to split it into 2. Okay, so this will become simply 1 by 2 pi integral 0 to 2 pi x into sine 1 plus n into x, okay, plus sine 1 minus n into x. Okay, I am writing it together. If you want, you can split it and write, no issue. Okay, now we will integrate. Okay, it's very simple. So using the induction by products parts itself, you can do it. So it will be simply be 1 by 2 pi into integral x into the integral of this one, that is minus cos 1 plus n into x by 1 plus n plus minus cos again 1 minus n into x by 1 minus n. Okay, that's the integral of this part. Okay, I'm taking it together. If you want, you can do it separately also, no issues there. Okay, and similarly again the next step would be derivative of x, which is 1, and again integral of this one, that is nothing but minus sine 1 plus n into x by 1 plus n the whole square, again minus sine 1 minus n into x by 1 minus n the whole square. Okay, and the entire thing you have to apply the limits from 0 to 2 pi. Okay, so please correct me if there is any mistake here also. So this is the integration. Okay, so when you substitute these values, what will you get? You will be getting this as, I think it is 1 by 2 pi is there. So when you apply this 2 pi here, it will be 2 pi into minus cos 1 plus n into 2 pi. Okay, so this is basically a multiple of 2 pi. 1 plus n is always an integer. One multiple of 2 pi, it will always be value is 1. So it is minus 1 by 1 plus n. So here also it is 1 minus n is always an integer and multiple of 2 pi. So it is minus 1 by 1 minus n here itself. Okay, minus, when you substitute 2 pi here, it will be sine of 1 plus n into 2 pi, which is a multiple of sine 2 pi, which is always 0, and here also we will have sine of 1 minus n into 2 pi. Now this is a multiple of integral multiple of 2 pi, so this quantity also will become 0, so that will be 0. Now when you substitute the value of 0, the x would be 0, okay, and this quantity will become 0, and sine zeros also will become 0. So that's it. So this is the answer. So if you simplify this 2 pi will get cancelled out. Minus 1 we can take it outside. So it is minus 1 into 1 minus n plus 1 minus n. So it is 1 minus, if you take LCM, 1 minus n plus 1 plus n by 1 minus n square. So it is 2 by 1 minus n minus 2 by 1 minus n square, or it is simply 2 by n square minus 1. So this is the value of an. Okay. So I hope it is clear. It's just substitution, and you have to apply the integration of parts, and you have to know the values of sine 2n pi, cos 2n pi, etc. Okay. But there is a slight problem in this this formula. The problem here is that if you look at this step, the step which from where I got the integral. Okay. If you look at this step, you have taken the integral of sine 1 plus n by 1 by x, there is no issue here. But when you take the integral of sine 1 minus n by x, you have got it as cos 1 minus n by x by 1 minus n. Okay. Now this integral is true except when n is equal to 1, this value is not true because the denominator will become 0. Okay. So for when n is equal to 1, you can't use this formula, and hence this will not be true because your n is equal to 1, this expression is not defined. So you have to separately take the case when n is equal to 1. Separately you have to deal with the case when n is equal to 1. Okay. Such type of situations will usually arise when you have two sine functions, two cos functions, sine and cosines, etc. Okay. So in those cases you have to separately deal with n is equal to 1, because when you integrate you will be getting some 1 minus n in the denominator, and it is not defined when n is equal to 1. Okay. So you have to separately deal with the case when n is equal to 1, which means that you have to separately find the value of a1 here. Okay. Similarly, when you find bn also, the same thing will occur. You will get the value of bn in terms of everything, but there also there will be factor of n minus 1 in the denominator. So you have to separately deal with the case when n is equal to 1, that is separately you have to find b1 also. Okay. So that is also clear. So let us try find out the value of a1 here. Okay. So how will you find out the value of a1? So your function is basically x sin x, place, I think it is x sin x itself. Okay, x sin x. Okay. So you have to find a1. So it is very simple. Just substitute. You have to find integral 0 to 2 pi. So when a1 is there, your cos nx would become just cos x. So cos x dx. So directly to compute it, how will do it? So this is sin x cos x. So I can consider this as 2 sin x cos x. So it is sin 2x. So it will be simply be 1 by pi into integral 0 to 2 pi. If I take x by 2, this will become 2 sin x cos x. So it is sin 2x dx. Okay. So 1 by 2 pi now. When integrate using parts, it is x into minus cos 2x by 2 minus x derivative is 1 again minus sine 2x by 4 in the limits 0 to 2 pi. Okay, when you substitute it here, it will be 1 by 2 pi into again 2 pi into minus cos 4 pi. 4 pi is again multiple of 1, cos 4 pi is always 1, so it is minus 1 by 2, but sine 4 pi is again 0. Again, if you substitute x is equal to 0, this will become 0, this will be also become 0. So ultimately the answer, I think it is minus 1 by 2. Okay, so that is the value of a1. Okay, so now you have got values of a0, a1, a. Okay, so remember the case why we had to separately find a1, because in the derivation of an you had a factor of 1 minus n in the denominator, and it was not valid when n is equal to 1. Okay, that you have to be careful. Okay, so I hope that is also clear. So similarly, find out the values of bn, okay, and find out the values of b1 also, because when you find out the bn, I think you will have the possibility of 1 minus n. If there is no possibility of 1 minus n, there is no issue, you can straight away find out the answer. But if 1 minus n or n minus 1 is coming in the denominator, you will have to separately find out the value of b1 also. Okay, so please try that by yourself. It's simple calculation only, just like ans itself. So I have given the calculations also here, you can just verify it for you. Okay, so that's it. So we have found out the value of a1 here. Again, you find out the values of bn by simple substitution. So when you find bn, you have sin x, sin nx. So there you have to use the formula of 2 sin a sin b. It is nothing but cos a minus b minus cos a plus b will be there. So you have to use that formula. So in that case, just check it out what is happening here. So that is also there. Okay, you will be using this formula. Okay, so again there is a factor of n minus 1 here. So you have to find out the value of b1 separately. So when you find out the value of b1 separately, you will be dealing with x sine square x. And how will you integrate x sine square x? You have to change sine square x to 1 minus cos 2x by 2. Using that integration, you can find out the b1. Okay, so please complete that also. I have already given it here. You can verify if you want. Okay, it's the same thing. Okay, so I hope that is also clear. Finally, you can give the final answer. Okay, and similarly, these are other problems are also there. You can try it by yourself. I'll just give you a brief hint also. So here you have the function f of x is equal to mod x. The interval is minus pi to pi. So you can use the properties of even and odd functions. Okay, now mod x is an even function because mod of minus x is again mod x only. So mod x is an even function. So your a naught would be 1 by 2 pi integral minus pi to pi mod x dx, but this is actually 2 by 2 pi integral 0 to 2 pi 0 to pi mod x dx. Now in this interval 0 to pi, your mod x is always x itself, so it will simply be 1 by pi into integral 0 to pi x dx. Now we can easily integrate. You cannot integrate if it is mod x dx, but in the interval 0 to pi, your mod x is always x. So now we can directly integrate. I think it will be written as x square by 2, that is pi square by 2. So the final answer would be, I think it is pi by 2. Just verify it. So you can find a naught. And when you find a naught, you will have an. It is actually, you need to find 1 by pi into minus pi to pi mod x into cos nx dx. Now mod x is even, cos nx is even. So this integral will become 1 by pi into 2 times integral 0 to pi x cos nx dx. Now we can apply the integration by parts. It will become mod x cos nx dx, but it is in interval 0 to pi, so it will simply become x cos nx dx. Now we can give the integration by parts and you can find out the value of an. And the calculation of bn is very simple, because when you consider bn, you will be looking at the function mod x into sin nx dx. Now you know that sin is odd, mod x is even, so this entire thing will become odd, so the integral will simply become 0. Okay, so only bn terms will not be there, only an terms would be there. Okay, just find out expansion, and in that expansion, when you substitute a corresponding value, if you look at the expansion, you will know which value substitute. Most probably it will be either 0 or pi or minus pi. So just try it out and write down the final expression, and then just substitute the values. You will be getting the desired expression. Okay, so I hope that is also clear. I have given the formulas here. You can try it by yourself. Okay, so that this is we can hear. Okay, so here they have actually put x is equal to 0. This was the expansion. So when x is equal to 0, you need expansion as 1 by 1 square plus 1 by 3 square plus 1 by 5 square. That means you have to make all this cos as 1. So the most obvious choice is obviously this x is equal to 0. Now x is equal to 0 is a point of continuity, so left hand side would be 0. So this will become pi by 2 is equal to 4 by pi into this quantity will become, and when you take 4 by pi here, will be get multiplied, it will be simply be pi square by 8. Okay, it's very straightforward calculation. Please try to do it by yourself. Okay, so that is another problem, and this is another problem in which you are being given a piecewise defined function also. This also you can easily do because there is nothing new. Only thing in these type of problems is that your f of x would be, there will be two integrals. You have to, when you find f of x a0 and bn, you will have to integrate from 0 to 2 pi, but when you integrate, you have to split the integral. Okay, for example, in this function, I need to find a0, the value of a0 would be 1 by 2 pi into integral 0 to 2 pi f of x dx. Now f of x is piecewise defined, so it will be 1 by 2 pi into integral 0 to pi, till that place your f of x is x dx, plus integral pi to 2 pi, again it is 2 pi minus x dx. Only this is the difference. Your integration will be 2 times. It will be, has to be split up. And don't forget to put the bracket outside and 1 by 2 pi outside, otherwise you will make mistakes with the coefficients. Okay. Similarly, when you are finding f of x into cos n x also, this interval from 0 to 2 pi has to be split into 0 to pi and pi to 2 pi. Okay. So please do that also. So it's very simple, you just substitute those values. Okay, and most probably you will have to substitute some values there also. Okay, just substitute the values and think what you have to substitute there. Okay, it's very simple. So this is the expansion. Okay, so I hope this is clear. So these are the Fourier series problems based on functions of period 2 pi. Okay, in the next session we will be discussing with functions of general period. Okay, the expansion is just the same, a minor change in the expansion is there, but the problems and everything will be just the same only. Okay, if you know the formulas, you can directly find out the values. Okay, thank you.